Hello boys and girls, I hope you had a lovely day off yesterday and had some fun. So today we're going over step 1, paper 3, which I hope by now you have done. Okay, and remember it was for 20 minutes. So these first wee papers are for 20 minutes long, and then the next set that we'll be doing will be slightly longer. So first one, Sean notices that when he adds the second prime number to the 7th prime number. So first of all, we need to work out what the second prime number is. So the first prime number is 2, okay? And remember, prime numbers can only be divided by themselves and 1. So the only even prime number is going to be 2, because all other numbers that are even numbers can be divided by 2, like 4, 6, 8, and so on. So anything that can be divided by 2, 3, 5, and 7 is not going to be a prime number. And the only exception to that are the numbers themselves, because they can be divided by themselves and 1 without leaving a remainder. So the next prime number is 3. 4 is not a prime number because it can be divided by 2. Then 5, 6 isn't a prime number because it can be divided by 2 and 3. So 7, 8, even number, isn't a prime number. 9 can be divided by 3, so it's not a prime number. 10 can be divided by 5 and 2, so it's not a prime number. 11, 12 is an even number, can be divided by 2, so 13. 14 can be divided by 2, so it's not a prime number. 15 can be divided by 3 and 5, so it isn't a prime number. 16 isn't a prime number because it can be divided by 2 and 8, and also 4 into 16 goes 4 times. So 17, let's see where we're at. 1, 2, 3, 4, 5, 6, 7. Okay, so he notices that when he adds the second prime number, which is there, to the 7th prime number, so 17 plus 3, he gets 20. So we know we're right. What number would he get if instead he subtracted the second prime number from the 7th prime number? So that would be 7, take away 3, and you know that would be 14. Okay, so on to the next one. It says, look at the 4 numbers below. Take the number in which the 7 stands for 70. And you know that 70 is 7 tens. So we are looking over here for a number where there's a 7 in the tens column. So let's have a look. We know that that's the tenths column. We know that's units. We know that's tens. And we know that that is the thousandths column. So we need 7 in the tens column. That's the tenths column, so we don't want that. 7 in the tens column, that's a units column. This is the tens column, so it's that one there. It's this one here, because that's the 7 in the tens column. Okay, so to make the sequence of numbers, you add 4 to the previous number for each of the new numbers. Now we had one like this last week, if you remember. So when you're going this way, you'll be adding on 4. And if you remember, I said to you last week, if we were trying to find out the numbers that came before, we would do what's called the inverse. That's a maths term. The inverse, that just means the opposite. So if we're going forward, we're adding on 4 because that's what it told us we had to do. And if we're doing the inverse, we're going to have to take away 4. Now, let's make sure that we've got this right, okay? So 22 take away 4 gives us 18. We're right there. 18 take away 4 gives us 14. And 14 take away 4 is going to be 10. And 10 take away 4 is going to be 6. Okay? So the next one says, only one of these numbers is a factor of 15. So let's brainstorm the factors of 15. So we always start off with 1 because that's always a factor of a number. So 1 times what will give us 15? 1 times 15 will give us 15. Now, it's an odd number, so we know we can't have a factor of 2 because it'd have to be an even number to have a factor of 2. So let's go on to the next number, 3. 15 times 3 will give us 5. 15 times 4, and we can't do that because we know it's not an even number. Next one, 5. 5 goes into 15 3 times. And we know we can stop because, look, we've got the same numbers now, okay? So the factors of 15 are 1, 3, and because the numbers are doubled, you still only count that as one factor, 5 and 15. So let's go over here and see if we can find any of them. 4, no, 5, yes, it's 5, okay? And it says to tick, so we will tick. Okay, next one. Look at this number line. What number does the arrow point to? So write the number in the space provided. So first of all, what we need to do, it's going from 10 to 20. So we need to count and find out how many spaces there are between 10 and 20. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 spaces, and we know 20 take away 10 is 10. So 10 divided by 10, so each one of these is worth 1. So what's going to come next? So 10, 11, 12, the arrow's pointing at 13. I'll just check. 14, 15, 16, 17, 18, 19, 20. That was an easy one. Sometimes the intervals in between are maybe worth 2 or 5, or sometimes it can be a decimal as well, but we'll work up to those, all right? So remember, always count the spaces and then work out what the difference is and divide that by the number of spaces you have. But don't worry, we'll come and do lots more of those. Okay, so this week in your practice paper, you've got a poem. Sometimes it can be a poem, sometimes it can be a piece of fiction, piece of non-fiction, sometimes it's even a bit from a play script. Okay, so let's read the poem. I love my books. They are the homes of queens and fairies, knights and gnomes. Now, you know what a gnome is, don't you? Some people have them outside in their garden and they've got wee funny hats. Each time I read, I make a call on some quaint person, large or small, who welcomes me with hearty hand and leads me through his wonderland. Each book is like a city street, along whose winding way I meet new friends and old who laugh and sing and take me off adventuring. Okay, so which one of these words used in line 8, so let's go to line 8, okay, which is this line here, because you can see from over here, is a verb. Now remember, a verb is a doing word, something that you do. So, and leads me through his wonderland. So leads is going to be the verb because that's the doing word there. Okay, the adjective winding in line 11 means, so let's go to line 11, along whose winding way I meet. Now, you think about a path. So if a path is winding, it wouldn't be straight. Okay, so think of a path going through the forest. It wouldn't be straight. So would it be blowing? No. Would it be long? Well, it could be long, but that's not what it means here. Is it noisy? No, I don't think so. I think the word is twisting. Okay, so you think of a path that would be twisting. All right, in other words, it wouldn't be straight. Okay, which of the following words from the poem is not a noun? Now, you remember a noun is a naming word, so it's a person, place or thing. So, queens, well, think of our queen. Is she a person? Yes, she is. Okay, knights, now look how it's spelt. It's not N-I-G-H-T, it's K-N-I-G-H-T, so that's a knight, like of the round table, who would wear armour. Is that a person? Yes, it is. And there's person, which is a person. So, in this one, it's saying which is not a noun, and it's quaint. Now, quaint means of some quaint person, large or small. Quaint, you would find people would talk about quaint Irish cottages, or that was something quaint in somebody's garden. So it's definitely not a noun. Okay. Okay, so going back to this one here, I forgot to explain to you what quaint means. Quaint means charming. Okay, so what are the coordinates of X? Now remember, when you're doing coordinates, okay, you go along and then up or down. All right, now in this one here, we've only got an X and a Y axis. Whenever we get a bit more confident, you will be having coordinates. We'll be working out coordinates on 4 quadrants, which means that there'll be another one here, another one here, and another one here. But don't you worry about those yet, okay? We can do these and we can do those well. We're flying at the minute. All right, so what is the coordinate of X? So remember what I said, you go along first. So that's 2, and then we go up. So the answer is 2, 2. Okay, so complete the number statement below by writing the missing number in the space provided. Remember what I told you last week? It's an equals sign. So whatever the total is on this side, the total's going to have to be exactly the same on this side. So let's have a wee think. 2 times 50. Now, if you're not very good at multiplying big numbers, let's break it down. So you know what 2 times 5 is, don't you? You know that 2 times 5 is 10. But this is 2 times 50. So then multiply your answer. So 2 times 50 would be 100 because we multiplied the answer by 10. So on this side, 4 times what is going to give us 100? Now, you should be able to work that out in your head, that 4 times 25 is 100. But if you can't work it out in your head, do a little sum. All right? And you'd be able to say 4 goes into 10 2 times and carry your 2. And then 4 goes into 20 5 times. All right? Remember these ones, equal sign. Whatever the total is on that side has to be the same on that side. So write the output of this function machine in the box provided. Now it's asking you for the output, so we're going this way. Okay, if it was asking you for the input, we'd be working backwards. So this one's straightforward. So 5 plus 4 is how much? So 5 add on 4 is how much? And 5 add on 4 is 9. So that one's easy. Okay, these shapes are drawn on 1 centimetre squared paper. That would be just like the paper in your maths book. Which shape has the greatest area? So I find this a wee bit hard to see. So I'm just going to make this a wee bit darker for myself. So the greatest area will be the one that has the most number of squares, that takes up the most number of squares. So let's count 1, 2, 3. That one's got 4. 1, 2, 3, 4. 4. These are all 4 centimetres squared. Sorry, I should have put my label in there. 1, 2, 3, 4, 5 centimetres squared. 1, 2, 3, 4 centimetres squared. So which one's got the greatest? It's D. Asks us to tick, so we tick. Okay?